Hi, Algebra 2 students. We are moving on with our transformations, and today we're looking at reflecting functions. So reflections, you know what that is when you look in the mirror, looking all pretty. Same thing for graphs. It's just talking about all the different things that we can reflect over. So the first one says the linear function f of x equals 2x minus 4 is shown on the grid, which you can confirm that. You know y equals mx plus b, so starting out at -4 right here, and then a little slope of up to right 1, we're good to go with that. All right, so that's the graph that you're looking at. So it says consider the function g of x that would be equal to negative f of x. Determine the equation and graph it. All right, so if we're saying that g of x is equal to negative f of x, let's really take the f of x function and negate it. So we're going to do a negative and then of the quantity 2x minus 4. And I'm putting parentheses, around it because you have to negate the whole darn thing, right? Which simply means distribute that negative. So it becomes negative 2x and then plus 4. That should be the g of x function. Now it says graph it. All right, I'm going to use my blue pen for this. So when I graph it, I'm going to come on over to plus 4. 1, 2, 3, 4. And then I'm counting out my slope of down 2 and over 1. Now, if for some reason you're not remembering how to graph stuff, you definitely need to review it, but you could use your calculator in theory to help you here. All right. So don't forget that you have that as a little crutch if needed. All right, line it up nice and pretty, and then let's label it. So here's our g of x. And keep in mind the original, that was our f of x right there. All right, how is the graph of f transformed to produce the graph of g? All right, well, they're saying, like, what happened to this solid black line that produced this guy? There's technically more than one way that you could answer this, but a consistent way. Think about it in terms of reflecting. What are we reflecting over? I can specifically focus in maybe on the y-intercept itself. The y-intercept started, right, at 0, -4, and it landed at 0, +4. So to get this point to land up here, think about what you had to reflect it over. Should be the x-axis, right? So it's a reflection over the x-axis, which, what does that really mean? Well, all the x's stayed the same, like 0, 0, right? So it keeps the x value the same. And then what happened to the y? Well, it went from -4 to +4. Or you could look at a couple other cases. You know, here it goes from -2 to +2. It simply just negates the y value. So that's the easy part. And hopefully you remember that from last year. So when it says, all right, now let's consider the function h of x equals f of -x. So I'm going to grab a different pen color because I have a different pen color sitting here. If you don't, not a big deal. So h of x is going to be equal to f of -x. So take that same original equation and let's put -x in place of where the x is. So just going to put a negative here, and I can clean that up, and it makes it -2x minus 4. So that's my h of x function. All right, graph this. That means I start down at -4, and then my slope down to right 1, or it might be more productive to go up to left 1. So repeat that a couple times over, and then go grab your straight edge and make a lovely straight line out of it. All right, and don't forget to label it. So this is our h of x now. So when it says, how is the graph of f? So that's the original line, transformed to produce the graph of h. If you look, and we could pick a couple points to focus in on. If we take the point, I'm not going to use the y-intercept because it happens to be the same, but I could take this point. This is the point 1, -2. And that ends up landing over here at -1, -2. Then we can kind of see that The y values this time stay the same, and it's the x's that are changing because we're reflecting over the y-axis. So it is a reflection over the y-axis. Oops, I'm so sorry. Right off the page there. And then what that means is that you negate the x values and you keep the y values the same. So the exact opposite of what we had last time. So you have to kind of keep in mind, if I'm flipping over x, x actually stays the same and the y is the opposite. If you flip over the y-axis, right, the y values actually stay the same and the x is the opposite. But if you can visualize it, it's easier to kind of just look at it and figure it out versus trying to memorize a particular rule. At least that's the way that I've always been able to understand it. So hopefully if you see it, it'll make it a little easier. So down here, when it says the function negative f of x, reflects the function across the x-axis, because that was the first case. F of negative x reflects the function across the y-axis. And for those of you, if you did memorize the rules last year, then you might have remembered saying like, all right, keep the x, negate the y. So negating y is the same as negating f of x. Or keep the y and negate the x, which is what you're looking at here. Right? So for this first one, it says, given the square root of x, sketch the function in each of the following. All right. If you are not familiar with this one, that's why you have a calculator. You can go right up in here and square root of x. And if I zoom 6, just to make sure I'm on that home screen, you kind of get half of a sideways parabola. It might not be completely obvious that that's what you're looking at, but I promise it is. So it kind of looks like this. And its starting point is right on the origin of 0, 0. So now I'm going to ask you to do negative f of x. I want you thinking before you graph it. If we negate the whole thing, you should be flipping it over the x-axis. So if you took this and flipped it over, hopefully it will match what you think it should. So if I do negative square root of x like this, and then graph it, there it is. There's that bottom half. So it would just be this piece of it. And then think about what would f of negative x look like. When we negate the x itself, then we're flipping it over the y-axis. So if you were to take this and flip it over the y-axis, what should it look like? And then same thing, you could confirm it here. How you would put that in the calculator would be square root of negative x like that. There's the original, and there's the other piece of it. So it'd be this side over here. All right, so it's changing the domain. This one actually changed the range. That one changed the domain. So this was negative square root of x. This one was square root of negative x, right? Because you're not allowed to take square root of negative numbers. So that's why the domain changed. Because if I plug in a -4, negative of -4 would be +4. Now I can take the square root of it, right? Don't overthink it, but there's a reason it changes. Moving on over onto the next page. We've got a couple where we're going to mess with the graph. We're also going to mess with the equation. So this first one, you're given the graph already. It says you have the parabola of what? F of x equals x squared minus 6x plus 5. It's already graphed for us, which saves us some time. It says consider the function g of x equals negative f of x. Determine the equation for g of x, and then graph it. And then same question, how is it being transformed? So if we look at the equation piece of it, this is the part that I kind of like here. We're saying negate everything that is f of x. So we're going to negate this entire thing. So big old set of parentheses here, x squared minus 6x plus 5. For what that means for us, we are distributing that negative. It is now negative x squared plus 6x minus 5. That is your new g of x function. And even if you haven't done these in a while, hopefully what comes to mind when you see a negative x squared is it's going to be a parabola that's upside down or kind of that like frowny face looking guy. So if we go to our calculator and we type it on in, let me get rid of that. So if we have x negative x squared and then plus 6x and then minus 5. Now I'm only graphing our new function, not graphing the original one here. That's what we expected it to be. So this kind of upside down parabola. Now, could I go to the table so I can plot some exact points? Of course. Right? If you can't see mine, then make sure that you're doing it on your own calculator so that you can see them accurately. But I've got 0, -5. So 1, 2, 3, 4, 5. And then I'm at 1, 0. I see we have 2, 3, 3, 4. And then it comes back down. We've got 4, 3, 5, 0, and then on to 6, -5, because we know how nice and symmetrical our parabolas are. So doing the best you can, connecting those points nice and smoothly. All right. So let me zoom back out a smidge here. And when you look at it, we've simply taken that parabola and flipped it completely upside down. So when it's saying, how is the graph transformed? It's a reflection over the x-axis. So once we start to learn those rules, could we have taken each point and just walked it across and negated the y value? Absolutely. All right. So if you didn't have your calculator, you can still produce an accurate graph. So the second part, when it says now consider the function h of x equaling f of negative x, right? Same as we did last time. Everywhere there's an x, you're going to put negative x in. So it's now negative x quantity squared minus 6 times negative x, and then plus 5. So when you clean this up, don't forget, doesn't matter. When you take and square something negative, it will always come out positive. Negative 6 times negative x becomes positive 6x, and then plus 5. That is our h of x function. Now, based on the fact that it's f of negative x, should mean that we're reflecting it over the y-axis. But you can use your calculator to confirm that. So I'm going to come on up here and type in x squared plus 6x plus 5 and graph it. And there we go, right? It's on that left-hand side over. So I can use my table to plot exact values if I need to. Maybe I'll slide this back a little bit. So at -5, it should be 0. So 1, 2, 3, 4, 5. At -1, it should be 0. At -4, it's -3, and so on. Right? And then it shares that point at 0, 5 right there. So let me find its match. Here we go. All right, and this is our h of x function. Oops, I actually forgot to label the last one. Not the end of the world. That's the nice thing about having the color, and then you can kind of keep track of what's going on. So notice how that one point, that y-intercept didn't change, because if you reflect over the y-axis and it's on the y-axis, it doesn't move. That is called an invariant point. So when you think about something varies, it changes. Invariant means points that don't move when you're reflecting. Right? And that's because they lie on the line of reflection, or sometimes, and perhaps the point of reflection back in geometry. All right, we're going to do a couple of these together. We're going to save a couple of these for class tomorrow. So example 2, we are going to do together. It's saying if a parabola has the equation f of x equals 2x squared minus 3x plus 8, which of the following represents its equation after reflection in the x-axis? So I'm really asking you two things. I'm asking you, do you know what part to negate? Are we negating f of x, or are we negating just plain old x? And then can you clean it up correctly? So feel free. Look back at that first page if you're not sure. It's written there for a reason. So if we're reflecting over the x-axis, come on back here. over the x-axis, that's the first one. You're negating the whole thing. So keep practicing it. Keep looking until you've committed it to memory. So we want to negate the entire thing here. So if we do negative f of x, then we would have negative 2x squared minus 3x plus 8. All right, clean it up. Negative 2x squared plus 3x minus 8, and then you're looking for that answer. So these are both positive guys, and then between the other two, it looks like we are looking at this guy right here. Now that's an algebraic way to approach it. Anytime you're given multiple choice, there is nothing wrong with doing a little bit of working backwards. So when we do this next one, you can do an algebraic approach, or you could kind of work it backwards. And what I mean by that is like a process of elimination. So it's saying after a reflection in the y-axis, which one would be the correct equation? All right, well, your other option for this is to type the original into y1. So let me do that. So I get 4x squared minus 7x plus 2. And let's see if we see this thing when I go to graph it. Yeah, we see it pretty nicely. All right, so we're looking for which one is the answer after you flip it over the y-axis. All right, so visually, when I flip it over the y-axis, it would still remain a parabola opening up, right? It would just be more to the left-hand side of that y-axis than to the right. So these first two choices, these would both be parabolas opening down. Both of these, because of that negative, would open down and open down. So I'm not even going to waste my time with those two. Of the remaining two, I could type into my calculator and see which one makes sense. So if I try number 3, this is for, let's see, x squared plus 7x plus 2, and I graph it. I'm looking for the one that looks like it's bounced over the y-axis. Actually, that looks pretty darn good right there. Now, am I always a little bit wary if I hit the right answer first? Sure. So I could double check the second one. The only difference with the second one is that there's a minus 2. So let me adjust it just to convince myself and convince you. There's the original. All right. And then the second one, you can tell it's been shifted down. It's not going to make any sense. Keep in mind, if we had done this algebraically, you'd be looking at doing f, or excuse me, in this case, g of negative x. So you would have typed in negative x here, and then negative x, and then take it from there. This would clean up to a positive. That would flip to a positive. That would stay a plus 2 right there. That confirms our answer. Okay, one last one to look at on this video together, which is perfect timing because we're hitting just about the end of where I want to be. And that is example 5. So last one here, saying if the point -3, -5 lies on the graph of some function h of x. So I don't know anything about it other than that one point. Which of the following points must lie on the graph of the function negative h of x? Well, if I have the point -3, -5, and I'm talking about the function negative h of x, 2 ways that I can think of that. One thing to keep in mind is h of x is a fancy way of saying y. So they're literally saying negate the y. Well, if I take this and I negate the y value, that would become the point -3, +5. And that would give me choice 2. The other way to think of this is, all right, if I negate the h of x function, again, we can go back to that first page and remind ourselves that when you negate the whole thing, you're flipping it over the x-axis. So if I want a more visual approach, I can think of the point -3, -5, let's say it's down here somewhere. And if I flip that over my x-axis, it's going to pop up here, which would make it the point -3 and then +5, which confirms that answer we just came out with. Right? So use all of those facets to make sure that you understand how to approach the question. As for example 4, we're going to save that little baby for the recap. And same thing with example 6. So when we come back together, we'll look at those ones as a little like warm up before we work on the homework together. All right. Have a good one, guys.